Hey guys, I hope you're doing great today. Today, we are going to start with our chapter number 14 of our DevOps Roadmap 2024. And today, our topic is Docker volumes. Guys, we know that Docker containers are easiest to use with stateless applications because the file systems of Docker containers is ephemeral. Ephemeral. What does this mean? If the container is deleted, the data on that container residing on that container would be deleted. So if you're working on a container and you are making some changes on that container, the changes would be lost if you remove the container. Therefore, we need a permanent solution where we can store our data, whether we are removing the containers, stopping the containers, or killing the containers. For instance, if I am running a container and a database is involved in that container and I have to secure and keep my data. So what would be the solution? The solution is to create a Docker volume and attach that Docker volume, or you can mount that Docker volume to that container. After that, when the Docker volume is mounted, remove the container, the data or the volume would be saved, and we can rerun the container or spin up a new container and attach that volume to the container. So in short, the Docker volumes offer persistent storage that is independent of the individual containers. For instance, when we create a Docker volume, let's suppose we have created this Docker volume. Now I can attach it to a number of containers at the same time. So it means that it is not dependent on a single container. This can be container 1, this can be container 2, or this can be container 3. So the Docker volume is independent. Now let's suppose that one of these containers gets failed. This container is not working, so I will spin up a new container and I can attach that Docker volume to that new container. When we start the containers, we can easily attach the Docker volumes, and we can attach a single Docker volume to multiple containers at one time. So in order to understand more about Docker volumes, let's dive in detail. First of all, we need to understand that Docker volumes are required to store data outside the containers. So it means that whether our containers are failed or lost or crashed, our data would be saved. When we install Docker, this is one of the key points that you must remember. When we install Docker, a dedicated directory is created here, var lib docker, and this directory contains separate folders for volumes, networks, images, etc. So everything we create in Docker, for instance, we create a Docker volume, that Docker volume will be created here. And if we could create a network, it would be saved here. The Docker images are saved here. So var lib docker is one of the key directories to store everything about Docker. Guys, in order to understand the concept of Docker volumes and the importance of Docker volumes, let's discuss one of the key concepts about image layers and container layers. We remember in our Docker file section, we discussed about the image layers, right? For instance, we create a new image and we have from run, copy, cmd, expose, Docker file instructions, right? A Docker file contains all these instructions to build a container from scratch. Now we saw that practically that each instruction creates a new image layer. Now there would be a base instruction from, okay, and these would be all image layers, and source code, for instance, source and packages, etc., and cmd or entry point. These are all image layers. Each image layer is created when we use the build command to build an image. Okay, these are all image layer. And we know that Docker uses image layers to build an image. For instance, if I have 100 run instruction in a single Docker file, it means that there would be 100 image layers in that image. So when we run this image into the container, a runtime container layer is created. This would be a layer on top of these image layers, and I would say that this is writable and readable, so that we can write and read data on runtime when this container is running. So this is a container layer, and it stores the ephemeral data that lasts when the container is running. When I remove the container, the data would be lost, the data would be gone. So this layer contains ephemeral data or temporary data that is required to run this container, or that container creates when it is running. So when I remove this container, it means that the data on that container is lost. We don't have this data anymore because we don't have the container anymore. Now, for instance, I have a database application and I'm running a database container. I want to keep this data whether my container is stopped, whether my container is removed, or it is crashed, or it is failed. I don't want to lose my data at any cost. What would be the solution? The solution is Docker volume. This would be my Docker volume, and I can attach it to this container. Whether my container is failed, I would have this volume saved in var lib docker directory. Okay, so that volume can be attached to any container. Whether this container was filled, we can spin up a new container and attach that volume to the new container. Now we know the importance of Docker volumes. Docker volumes are used for persistent data storage, and we can create a Docker volume simply with the help of Docker volume create and my volume name. So Docker volume create the volume name and a new volume. For instance, I have the name as volume 1. New volume would be created here in var lib docker volumes folder. We will check it practically. Now I can attach this volume to container 1. For instance, I have this container running and I can attach this volume 1 with the container 1. For instance, if this container is failed or crashed, we don't have to worry about our data. The data would be saved in volume 1, and I will create a new container and I will attach or mount this volume 1 again with my container 2. So that's how volumes can be attached or mounted with a number of containers at one time. And again, let me repeat the concept. Volumes are not dependent of the containers. Whether containers are stopped or working or failed, our volumes would be saved, our data would be saved here in var lib docker volumes folder. and we can attach a single volume to multiple containers at one time. I hope that now you have these Docker volume concepts clear. Docker volumes are used for persistent data storage. When we run a container, the container creates image layers and we have a writable container layer. But when we run a container without a volume, if this container gets removed, the data would be lost. So for permanent data storage, we have Docker volumes. We can create Docker volume with Docker volume create command, and we can attach this Docker volume to any container for persistent data storage. And one more thing, that if our data is updated, it is automatically updated inside the container as well. And if there are any changes made with the data inside the container, that changes would automatically replicated here on our volumes directory on our host machine. If we make any changes inside the container regarding this volume, all those changes would automatically replicated here in warlib docker. We can the data, it means that the data is synced. When we mount any volume with the container, if there are any changes happening inside that container, those changes are updated automatically. So when we create a volume, a new folder would be created here. Okay, and if any changes are happening inside the container, all those changes are replicated here as well. In addition to that, for persistent data storage, we have another option which is known as bind mounts. Bind mount. So we have two options, volumes and bind mounts, to store our data. But the preferred mechanism is to use Docker volumes. Now let's discuss the difference between Docker volumes and bind mounts real quick. So we can create Docker volumes separately and attach them to any container. Whereas in bind mounts, we can mount a folder. It is a folder which is on my host machine. This is my host, and this folder is directly mounted on my container. So what is the key difference between a volume and a bind mount? Volumes are completely managed by Docker. And when we create a volume, a separate folder is created in warlib docker. And it is not dependent on the operating system of the host. It has nothing to do with the operating system of the host. Volumes are independent. Whereas in bind mounts, the bind mounts are dependent on the directory structure and the underlying operating system. So since volumes are completely managed by Docker itself, that is why we prefer to use volumes instead of bind mounts. And you must remember, and you must know that in bind mount, a folder or a directory on the host machine, this is my host machine, that folder is directly mounted inside the container. We will, of course, see it in our lab, how we can mount a folder and how can we create a volume and attach to the container. There would be a complete lab session. So now let's discuss a couple of Docker volume features. First of all, we know that the Docker volumes are used for persistent data storage. That is one of the key advantages or benefits or features of Docker volumes. We can easily back up and migrate Docker volumes among different Docker hosts. So the backing up and migration in Docker host is easy while we use the Docker volume. Docker volumes work both on Linux and Windows machines. This is also one of the key features of Docker volumes. They work smoothly both on Linux and Windows. And like we discussed before, we can attach a single Docker volume to multiple containers at one time, or multiple volumes can be attached to a single container at one time. So it means that Docker volumes can be shared safely among different containers. Also, we can store volumes on remote hosts and cloud providers. It means that with the help of Docker volumes, we can store them on remote host, other servers, and cloud providers. And also, we can encrypt our volumes. So, guys, these are a couple of major Docker volume features in which we can store our data persistently. We can backup and migrate our Docker volumes among different Docker hosts. We can run Docker volumes both on Linux and Windows machines, and we can create multiple Docker volumes and attach multiple Docker volumes to a single container, or a single volume can be attached to multiple containers safely. We can store Docker volumes among different and remote hosts and cloud providers, and we can also encrypt our Docker volumes. So I hope that your Docker volume concepts are now clear. Now let's jump in and start doing the lab. Alright guys, now let's start our lab. You can see I am logged in my VM. First of all, we need to understand about this critical folder we have, directory of Docker. It contains everything about Docker. When we install Docker on our VM, it is created by default. And for instance, we create volumes. The volumes are created here. We create images. We have images here, like containers and plugins, drivers, etc. Everything that we create using Docker commands is created here. We will create bind mounts and we will create Docker volumes, and we will see practically that those volumes reside here. That is why it is persistent storage. Everything that we create using the Docker volume create command, volumes are created here in cd volumes directory. Now these are just the default metadata database. Now, for instance, I create a new folder. Let's start from the beginning. Make directory and testing mount. We will test bind mounts first. Okay, bind mounts. Now this directory has been created, and we will mount this directory inside the container. We have docker ps -a. You can see we don't have any container running. Docker images, we have just one nginx image, and we have this testing mount directory, and I want to mount it inside the container. I will not create a Docker volume. We are going to first see how does the bind mounts work, because bind mounts are straightforward. You just mount any folder. For instance, I have node app, I have this multi-stage folder, I have this folder. We can mount any folder from our host inside the container. So that's why we are dependent of our underlying operating system, and volumes are independent. We can create volumes and we can attach them anywhere from anywhere. Now this directory would be mounted inside the container. And how bind mounts work, let's spin up our container. And first of all, you can see Docker volume ls. We don't have any volumes created as well, or any bind mounts. If we run the same command, it will show us the bind mounts as well, docker volume ls. Now let's spin up our first container. Docker run minus it minus d minus p, it is nginx. And I hope that you have practiced the docker commands and you remember them. So minus v, the v option is used for mounting and creating bind mounts. Minus v, now I have to give the full path of my this volume, my this directory, home, DevOps, Molvi, and testing mount. And this is actually my source, right? This is the path I am using from my VM. This is my source, and this is my target, which directory I need to mount on. And I am using opt. For instance, everything that I mount should be there inside the container's opt directory. And minus minus name of the container, container1, and the image, okay, nginx latest. So that is the command, guys. You can see docker run a container, interactive session, foreground, minus p, port, container, outside port 8080, minus v is the option to create the bind mounts. We will also check the hyphen dash dash mount option as well. So minus v is a bit simple, and minus v is used to mount. This is my source directory and this is my target directory. This is my host or VM. That is why bind mounts are dependent on the host. We have to give the full path. And this is my containers directory, and containers name, and the image name. All right, our container is up, docker ps. So we have our container running. Okay, now I will log into container, docker exec minus it and sh. You can see we have this volume created. Now testing mount was empty, guys. There was nothing inside the container, sorry, the folder. So guys, you can see that my testing mount folder was empty. Now I am inside the container, and in opt, because we mounted the opt directory inside the container, and our source directory was home, DevOps, Molvi, and testing mount as per the command. Now I will create a test direct file here, abc.txt. That file should be created on my host as well, ls-l. You can see this is created here in testing mount, because now the bind mount is working perfectly, and we have mounted this source inside the container's opt directory. Now let's create a file here and see whether the changes are replicated inside the container as well. This is interesting, by the way. Touch error.log. I want to create a log file, and I want to see whether I have this file inside my container. And yes, we have this file created inside the container. So guys, this is persistent storage, and all the changes are, inside the container, what is happening inside the container is being saved, and we should not worry about our data loss. So that's how bind mounts work. And we can create, should I create another one quickly? Okay, let's suppose I am creating another bind mount, and in which I will mount this directory. This is my node app, and we worked on our node application, if you remember, in our docker file section. And there is a lot of content here, about our node application, I will mount the whole folder, whole node app directory inside the container. Okay, now what would be the command? Cd, sorry, docker run minus it minus d minus p. I will run it on any other port to avoid the conflict. Minus v home DevOps Molvi. Now I have to give the complete path of my source folder, node app, and full. This is my, you can say, this is my target directory in the container. Minus minus name container 2 nginx latest is the image. Now our container is running. I can see two containers here, and this is our second container. Now I will log in docker exec minus it to check our bind mount. We are mounting our source folder inside the containers directly. These are bind mounts. That's how bind mounts work. sh cd home, and we should have all that data inside the container. So guys, I hope that you are now have a clear picture of how the bind mounts work. And now, for instance, if this is the file, uh, docker file, cat docker file, sorry, cat, I have to write it completely. Now I am making some changes from my bind mount. Now I would be creating some changes, and we will compare whether we can replicate those changes here. Clear cd home DevOps Molvi node app nano docker file. For instance, if I am changing anything, this is my change in the file to check bind mount. I've done this a little change in the docker file, and now let's see what's happening inside the container, whether we are replicating this change. Cat docker file, oh sorry, clear cat docker file. Okay, you can see we can see the changes we are creating in the files. So that's how our persistent storage work, guys, and that was actually the bind mounts. Now we are going to see how the docker volumes work. So I hope you have everything cleared about bind mounts. Now let's create our first volume. I will remove these containers to avoid any mess. Docker rm minus f, and both containers can be removed with this single command, docker ps minus a minus q, and my containers have been removed. Now guys, I will create a new volume. Volumes are independent, volumes are fast, and volumes can be migrated securely, volumes can be encrypted. We can create remote volumes on remote host or on our cloud providers. These are the benefits that we cannot get in bind mounts. That's why docker volumes are always preferred, and docker volume ls is the command to see whether we have any volumes created, and the answer is no. We don't have any volumes created. Docker volume create my first volume. Okay, now the volume is created, docker volume ls. can see it, and the default driver is local. Okay, the default driver is local. And now if I want to inspect and see more details about this docker volume inspect my first volume, sorry, you can see it was created at this time and its driver is local. This is the mount point. Now let us see the mount point, and it is here, cd var lib docker volumes. Guys, this is one of the key directories of docker, and it can be asked in your interviews that which directory contains everything about docker. So it's var lib docker. And volumes, we should see our first volume. My first volume is created here, and this is the sorry, okay, my bad. And this underscore data is the default mount point for this volume. Now everything we create inside the container and using this volume would be permanently stored here in this mount point. As per our inspection, we saw this is our mount point. Now let's create a new container and we will attach this volume to that container. Okay, and we will use the mount hyphen dash dash or hyphen hyphen mount option here in this command. The command would be slightly different. Docker run -it -d -p, okay, at:/at. Now minus or hyphen mount. Okay, now this is our command in which we are going to mount our volumes from our source directory. Now using this option, we are going to mount our volume, my first volume that we have just created, inside the target directory of the container. So we will have the source and target here as well. Mount now we will have to specify the source and target. So the source is equal to source. Okay, source is equal to the volume name, my first volume, and target is equal to, for instance, I am using this target again. We will use the home or any other directory as well. We can target any directory like the logs directory in Nginx as well. So that's how the syntax of this command. Now minus name of the container, container1, and Nginx latest is the image name. So guys, let me repeat this command again. Docker run interactive foreground minus port inside outside and minus mount. You have to focus on this especially. So this is the volume which is our source volume, my first volume, and this is my target. This first volume, source volume, would be mounted here, and this is our container. Let's see. Okay, our container is up and running. Docker ps. Now docker exec -it container id sh. So our mount point is opt. Okay, now something happening inside the container. For instance, we have a log file here, touch error.log, and this file is continuously updated. Okay, now this file is created and we should have this file here as well inside our mount point. You can see we have this error log file inside our mounting. So that's how it is secure way to store your data and our data would be stored. Now I can create any directory here inside the container as well. Make dir my storage, and this directory should be created here as well inside our mount point. You can see, so this is the volume. Now let us inspect the volume again. Exit, docker inspect my first volume. Okay, we can expect, and we can also inspect docker inspect container 1 pipe symbol grab volume. You can see this is the type of the volume and source, and this is the mount point. The container is also showing our the information about our volume. So guys, we should we should remember how this command works. This is really important. This is the mount option to mount any folder, any volume. You can see we don't have to give any source path. We are not giving any source path. We are just mentioning, giving the name of our volume, and it is mounted inside our containers opt directory. Now let's create another container so that we can revise this command. Docker container run -it -d -p 81:81 -mount. Okay guys, the commands should be practiced a lot. Again, I say it in every lecture so that you do not forget those commands. Now source is equal to, okay, my first volume. I will attach this volume to another container so that the second concept of attaching single volume to multiple containers is clear. And target is equal to /home --name container 2 nginx latest. We have this container running, and we are attaching our first volume inside the container 2's home directory. Now docker ps, and we have this container docker exec -it sh cd home. Now guys, you can see that whatever the content of my first volume we had in this is attached to the second container, and we have this inside the home directory. So that's how we can change the mount points. We can attach one volume to multiple containers. You saw we attached this first volume, only one volume, to two containers, and similarly we can create multiple containers and attach this single volume to multiple containers at one time. So that's how the volumes work. And now if I inspect docker inspect container 2 and grab volume, you can see we have the same, my first volume attached to this, and we have the same mount point for this volume. Now there is one interesting thing that I want to show you guys. For instance, docker exec, I'm going to create a change inside container 2 container, and we will see whether we have this change inside container 1 sh. Now the mount point is cd home of this container, touch new change .php. So make sure that you are making changes to the correct mount point. And now I have changed this in home, and let's see if we have this change in here. Okay, we have it in our mount point, you can see the file has been created. Now let's log in to the container 1 and see whether we have this change over there as well. Docker ps, this is my container 1, docker exec minus it container 1 sh, and the sorry, docker exec minus it, oh sorry, the command is incorrect. I got worried what's happening. So now the mount point is opt, okay, you have to remember this. Now we can see the change here as well. So single volume mounted on 2 containers, and we saw if the change is happening on 1 container, it is replicated across the mount point and other containers as well. So that was really interesting to see how the volumes work in Docker. So we can remove our volumes, docker volume ls, and for instance, if I am removing the container and there would be no impact on our volume, docker ps, and I am removing this container, docker rm. I have removed this container, and you can see our volume is still there, docker volume ls, but we cannot remove a volume if it is attached to any running container. Now let me remove this volume, docker, since it is still attached to the container 2. We have this container running, docker ps, you can see we have container 2 running. Now I want to remove this volume, and it will not allow me to remove because it is attached to a running container. Let's see this, docker volume remove rm, my first volume, and it is saying that the volume is in use. So until and unless we remove this container, then we would be able to remove the volume. Docker rm minus f, and now I will remove the container 2. Now we are able to remove the volume because it is not attached to any running containers. So that's how, guys, the volumes work. And we must know the difference between bind mounts. We have also checked how bind mounts work, but you saw that the Docker volumes are more resilient, and we can create volumes according to our choice. We can create multiple volumes, and we can create a single volume and attach it to multiple containers. So the following command is showing how we can create a mount point using the -v option to attach any volume. Docker run -it -d -p and container port 8080 -mount. Okay, and this is our source is equal to the volume name, and comma, this is our target is equal to any directory or mount point inside the container, like opt, or in case of logs, user share nginx logs directory. Okay, if I want to mount any volumes, log volume inside this container, and minus name of the container 1 and nginx latest. Now this would be our source, and this would be our target. If I do not create any volumes, it will automatically create a new volume. I didn't create any source volume, you can see, and it has created a volume with volume name, docker volume ls. So that if we do not create any volumes explicitly before, we can create on runtime using the docker run command. So these were the commands to create volumes. You saw how can we create volumes and how we can attach a single volume to multiple containers. Also, you saw that how we can remove a volume, but we cannot remove any volume if it is attached to a running container. So that was really interesting for me, guys. I hope that you will also practice these commands, and you will find really interesting. Please make sure to subscribe my channel, and if you have any kind of suggestions for me, please write in the comments. I will definitely read all your comments. I will see you in our next lecture, where we will discuss about uh, 50 Docker interview questions, and also we will discuss about the Docker networking. That is also something very exciting coming in, and then we will move towards our Docker Compose lectures. I really need your support. Make sure to subscribe my channel, and if you have any questions, please ask me in the comment section. Take care. Bye.